Hello, this is the recording for the Lab 3 in the course GIK2KM for Data Science and Machine Learning. So I've chosen the assignment 8 in the lab. So so to begin with, we were to separate the observed and the expected values. And as you can see here, I have loaded the whole data frame from a CSV file called personalities, and from the table that were assigned to us from the assignment itself, I've put in the observed values here, and the expected values is comes from the expected from the assignment itself, from the percent of the population. So red was suggested to be 25%, and blue was 30, and yellow and white was 20% each. That's why the expected values turned out to be 75, 105, 60, 60. And yes, so if I were to separate these two values and put them in two fields, I would assign them in two arrays. One which only takes the observed column, and the other one the expected column. Now, if I've done that, then it's easy for me just to perform to calculate the chi-square. I think it's called chi-square. I just use from SciPy stats. I import the chi-square and and feed the attribute observed field in this case. And in this case, I get the statistic 35.17 and a p-value. Since we have an e here, which means it's significantly below 0.05, which also gives us the answer to our null hypothesis rejection, which is also always if the p-value is lower than 0.05, then the H null hypothesis should be rejected. But as we can see here, if we do the same test on the expected field, we have we have a similar p-value, which means that there is a not there is we could say the H alternative would say that there is not a not a large significant difference between the expected and the observed value. There is a difference, but not a significant one, and you can also see that by just looking at it. Yes, and also to determine the expected count, we use the formula E equals the sum of the frequency divided by the number of categories. And to write out that mathematically, we just use the expected count equals to sum, feed in the observed field with the and divided by the length of the observed field. And in that case, we get the expected count. And the same goes if I were to do the same here and just feed in the expected field instead. I could calculate that one as well, and I just say maybe something like that. Run that one as well, and I say expected counts, and we get a similar value, which is also a you could say a sign that there is not a significant difference between the expected and the observed value. So thank you.